Today, we're diving deep into the world of security. That's right, we're going to learn how to protect against the sneaky and devious SOQL injection. Hi, I'm Simon, and I'm a Salesforce Developer at Smoothstack. But before we jump into the nitty-gritty, don't forget to hit that like button, subscribe if you haven't already, and ring the notification bell so you don't miss out on more helpful content. Tip number 1. Avoid dynamic queries unless they are essential for your use case. You can avoid the risk of SOQL injection entirely by using static queries instead. Tip number 2. Use string.valueOf and string.escape single quotes to treat all user input as a single string instead of code. Tip number 3. Sanitize your input data with client-side validations. Only allow the characters that are necessary and block anything suspicious. And tip number 4, if you've got an inside job going on, you want to limit the access your code has. Just like you wouldn't give a new intern access to the company's vault, don't give your code more privileges than it needs. Restrict user permissions to the bare minimum required for the task. Now let's see some of these in action. Are you ready?
Alright, so this contact data accessor class may look familiar to some of you, but we have added a new method to it called getContactsByName, and we take in the name as a string, and then we have a dynamic query that allows us to get the ID and name from a contact where the name matches whatever is passed in as this string, and then we return database.query passing in that query string. Now this is different from these other queries, which are all static queries, in that it uses this database.query, which makes it dynamic. So there is a number of ways that you can implement dynamic queries. Sometimes you need them because you're not sure what object you're going to be querying on, and sometimes it's because you're not sure if there are going to be additional criteria that you might want to filter on. So it provides some additional flexibility at runtime, whereas all of these, so for example this one where we have the brackets, we can only take in certain variables and match against those. It's not as flexible. But the big advantage of these static queries is that they aren't vulnerable to any sort of SOQL injection attacks. So ensure that you follow this basic pattern anytime your use case allows, but in the event that you need to use a dynamic query, I'm about to show you how they can be dangerous and go over a couple of ways that you can protect yourself. So I have a small example here, and we're just going to run it in execute anonymous for now, but imagine that you have an end user and they're interacting with something like a Lightning Web Component that makes use of this method in the contact data accessor. So if you're directly taking their input and passing it in as the query, then they could potentially enter something like this. Now this string clearly isn't the sort of input that you're expecting them to enter for a name field, but a tech-savvy user might craft something like this to try to get additional information from your database. And so let's go ahead and execute this and see what it does. In our logs, you can see that instead of just filtering on the name like we were expecting, we checked for any name, and then we also searched for an SSN that ends in these 4 digits. And so here we can see two users in the database that match on those last four digits. And so then, and again, this is a bit of an extreme example, but if you didn't protect your data whatsoever, an end user could potentially see these first and last names and this last four digits of the SSN and have access to PII that you really don't want them to see. And now, the first and most obvious way to prevent this is to restrict permissions on the SSN field. Naturally, you wouldn't want any user to be able to query for a social security number, so make sure that you don't provide users access to it unless that's absolutely necessary. Secondly, you can, as I mentioned before, cast as a string and use escape single quotes to ensure that this data is treated as a string and that it's treated as a singular string. So now let's go ahead and see what happens if we instead do the safe query using the same base string as evil query. You'll notice here we get nothing back because now instead of treating this whole string as code, the query is going to be treating it as a single string and searching for a name that matches this, which naturally wouldn't exist in the system. So what we can do to fix this is just add this line here to our method in contact data accessor. I copied that for a reason. And of course, it's not called evil query, it's called query. So we are updating the value there. And now, if we go back to our original attack with our Apex class updated, we should see, oh, that's not what I was expecting to see. Well, we all make silly mistakes sometimes. Just a few seconds after I popped off and popped back on, I realized that I was changing the query instead of the name. So instead, we want to say that name is equal to, and we'll call it string safe name. Yeah, we don't want to escape the entire query. We just want to escape the name. And so then here we'll use safe name instead of name. And let's go ahead and try that one more time. All right, we received success. And here it is demonstrating that we didn't get any results back from the evil query. So that is the best way to ensure that your strings are getting treated as strings instead of code. But there's one additional thing we can do. So I mentioned before, we need some way of getting this user input in the first place. Typically, we would be using something like a Lightning Web Component to display the data to the user and receive their input data. And I'll probably go a little bit more in depth on this concept in a future video, but it's best practice to validate the user's input data against expected characters to make sure that they're only inputting what we're expecting to see. So if we have a name field, I doubt that anybody is going to have a % and a \apostrophe in their name. So you would typically add some sort of validation to ensure that they're not entering character combinations like this, and they're instead entering valid names. But that's all for today. I will see you in the recap.
Protecting against SOQL injection is all about being the gatekeeper of your code, filtering out the bad stuff and making sure only the good stuff gets through. Remember, security is like a never-ending game of chess, and we always need to stay one step ahead. If you found this video helpful, give it a thumbs up and share it with your fellow developers to keep our coding community safe. And as always, if you have any questions or want to see more tech tutorials, leave a comment below.